What is matter made of? An atomic physics journey. Imagine you're standing on a sandy beach, letting the grains of sand slip through your fingers. Now, think smaller, much smaller. What if I told you that everything around us, from the sand on the beach to the stars in the sky, is made up of tiny particles called atoms? But what exactly are atoms, and what are they made of? Let's embark on a journey into the fascinating world of atomic physics to find out. The mysterious building blocks. Long ago, philosophers pondered the nature of matter and what everything is made of. They speculated about tiny, indivisible particles that formed the basis of all matter. These were the earliest concepts of atoms, but it wasn't until the 19th century that scientists like John Dalton began to describe atoms as real entities that make up everything in our world. But what's inside an atom? Imagine if we could shrink ourselves down to a size small enough to explore an atom. As we journey inside, we'd discover a whole new world filled with even tinier particles. The tiny nucleus. At the heart of every atom lies its nucleus, a dense, incredibly small core that holds most of the atom's mass. It's like the engine room of a ship, powering everything around it. Inside the nucleus, we find protons and neutrons. Protons are positively charged particles. They are what give an atom its identity. For example, a hydrogen atom has 1 proton, while a carbon atom has 6. The number of protons in the nucleus is called the atomic number, and it defines the element. Neutrons are neutral particles, meaning they have no charge. Their main job is to keep the nucleus stable by preventing the protons from repelling each other due to their positive charges. Imagine the protons as like-charged magnets, which would fly apart without the neutrons holding them together. Protons and neutrons themselves are made of even smaller particles called quarks. Quarks come in different flavors, but inside protons and neutrons, we find up quarks and down quarks. A proton is made of 2 up quarks and 1 down quark, while a neutron consists of 2 down quarks and 1 up quark. These quarks are held together by particles called gluons. Think of them as the glue that binds the quarks together. The cloud of electrons orbits the nucleus, and these electrons are much smaller and lighter than protons or neutrons. If the nucleus were the size of a marble, the electron cloud would be like a football stadium surrounding it. Electrons are negatively charged particles, and their movement around the nucleus creates the atom's size and shape. These electrons are arranged in different energy levels or shells, like layers of an onion. The electrons in the outermost shell are the ones involved in chemical reactions, making them the architects of all matter's complexity. So, what keeps the electrons in orbit around the nucleus? This is where the fundamental forces of nature come into play. The electromagnetic force is the attraction between the positively charged protons in the nucleus and the negatively charged electrons. This force is what keeps the electrons from flying off into space and holds the atom together. Inside the nucleus, the strong nuclear force is the superhero that keeps protons and neutrons bound together, overcoming the repulsive force between the positively charged protons. This is the strongest force in nature, but it only acts over very short distances, just within the nucleus. As we explore deeper into the atomic world, we encounter some strange characters. Neutrinos are nearly massless particles that rarely interact with matter, earning them the nickname ghost particles. They are produced in nuclear reactions, like those in the sun or during radioactive decay, and they pass through us by the trillions every second without us ever noticing. For every particle, there exists an antiparticle with the same mass but opposite charge. For example, the electron has an antiparticle called the positron, which is positively charged. When a particle meets its antiparticle, they annihilate each other, releasing energy. This is one of the most intriguing and mysterious aspects of the universe, hinting at deeper symmetries and the origins of matter itself. As we delve deeper into the atomic world, we enter the realm of quantum physics, where the rules of the game change dramatically. In this world, particles can behave like waves, and their exact position and momentum can never be known simultaneously. This is known as the Heisenberg uncertainty principle. An electron doesn't orbit the nucleus in a fixed path like a planet around the sun. Instead, it exists in a state of probability, where it can be in multiple places at once. This phenomenon is called quantum superposition, a concept so strange that even the greatest physicists struggled to comprehend it fully. When particles become entangled, their states are linked, no matter how far apart they are. A change in one particle's state will instantaneously affect the other, even if it's on the other side of the universe. This bizarre connection has puzzled scientists for decades and continues to be one of the most mysterious aspects of quantum mechanics. All the particles we've talked about, quarks, electrons, neutrinos, are part of what scientists call the standard model of particle physics. This model is our best understanding of the fundamental particles and forces that make up the universe. But the story doesn't end here. The standard model is incredibly successful, but it's not complete. Scientists are still searching for answers to questions like, what is dark matter? The mysterious substance that makes up most of the universe's mass but doesn't interact with light. What is dark energy, the force driving the universe's accelerated expansion? Why is there more matter than antimatter in the universe? These questions drive the ongoing exploration of the atomic and subatomic worlds. The journey to understand what matter is made of is far from over. Every discovery opens up new questions and mysteries. From the tiny quarks to the vast quantum fields, the story of matter is one of the most captivating and complex tales in all of science. As we continue to explore, who knows what new particles or forces we might discover? The adventure of atomic physics is an ongoing saga, with each chapter more fascinating than the last, and you're invited to be part of this incredible journey.